showing you how to use decision trees to predict house prices. So a decision tree is a flowchart like structure in which each internal node represents a test on an attribute. For example, when we flip a coin, if it's going to be a head or a tail, each branch represents the outcome of a test, and each leaf represents a class label. For example, here this this leaf node represents a class class of bedrooms. This represents class of lot size classes. So one thing is we have a root node. This the first leaf, this one is the root node, this node. So the root node represents an entire population or a sample, which is then further divided into other homogeneous sets. So we have a decision node. Let's say if we have a root node, and then these are decision nodes. So when a subnode splits into further subnodes, then it is called a decision node. So when this splits into subnodes, it is called a decision node. And then we have the terminal leaf. So a terminal leaf is a node that does not split. So as you can see here, let's say we want to predict the price of houses based on the bedroom class. So we first ask ourselves a question: does the house have two more than two bedrooms? If it's yes, we ask ourselves another question based on the lot size class: is the lot size larger than 11,500 square feet? If yes, then the price will be 233 US dollars. If no, then the price will be 170,000 US dollars, which is logical because if it's less than 11,500, it cannot be like it the price cannot be greater than when it is more than 11,500. And then on the other side, we ask ourselves, does a house have two bedrooms? If it's no, then we ask ourselves another question based on the lot size class: is the lot size larger than 8,500 square feet? If it's yes, then the predicted price will be $188,000. If no, then the predicted price will be 146,000. The other thing is decision trees can also be used, like for example, like banks can also use decision trees to predict if it's a good investment for them to give a loan to their clients based on their savings. For example, let's say we have the root node, and the root node represents savings, whether they are low, medium, or high. If the savings are high, we ask ourselves another question based on the income class: is the income of our client less than or equal to $30,000? If yes, then it's a bad risk. We cannot give him a loan. If no, then which means that the income may be greater than 30,000, which is a good risk. And then here you can see that if our client savings are medium, then it's a good credit risk. And then here, if the savings of our client are low, we ask ourselves based another question based on their assets. Are their assets low? If yes, then it's a bad risk. We cannot issue them a loan. If it's no, it means that their assets are high. It's a good risk, so we can give them a loan. So these are some of the common terms used with the decision trees. So I have put a link in the description, which a link in the description of this Jupyter notebook. So if you can want, you can go on GitHub, you can download the Jupyter notebook, and then you can play around with the decision trees. You can read what decision trees are and some of the things that I may have left. So what are the advantages and disadvantages of decision trees? The advantages are that decision trees are easy to understand, and it's easy to generate rules using decision trees. The other thing is that decision trees may suffer from overfitting. For example, when we are dealing with real world data sets, a decision tree can be very, very large and can get very, very complicated, which can lead to overfitting. So overfitting is a scenario whereby our model is is a scenario whereby our model does not generalize well. So our model is good at predicting something when it's given values that are similar to the training set. But when we give it like to predict on other values that our model have not seen, or on the data set in which our model have not seen, the model will have difficulties in making predictions. So the other disadvantage is that decision trees do not easily handle numeric data. And the other thing is decision trees can be quite large and pruning is necessary. So here I'll be using a decision tree regressor. So what is regression? So regression is a statistical measurement used in finance, investing, and other disciplines that attempt to determine the strength of the relationship between one dependent variable, usually denoted by y. In our case, the variable y are prices and other changing variables, which in our case, the variables are going to be bedrooms, land size, and so forth. So we want to determine the relationship between the bedrooms and the price of the house, like latitude and the price of the house. So here I have imported NumPy, which is a mathematical library, and then pandas, which we are going to use for preprocessing our dataset. So this is the file path, my file which contains the dataset, and then here I'm going to read the dataset into pandas, and then I'm going to store it, and then I'm going to store it in the variable df. So let's run our code. And then we want to get a description of our dataset. To do that, we use the describe method from the pandas library. And then if we want to display our columns, we can just use the dot columns from the pandas library, and then this will display columns in our dataset. For example, we have the suburb, address, rooms, type, price, method, seller G, date, distance, postcode, bedroom, bathroom, car, land size, building area, year built, council area, latitude, longitude, region name, property count, and so forth. And then the other thing is we want to drop now empty values. So here we specify the x is equal to 0. So when the x is equal to 0, we'll be among the along the y-axis. And then the other thing is we want to so here we want to create our target variable, which we will be predicting using our model. So our target variable in this case is going to be price. So we just say y is equals to df, and then we specify the column of the target variable, which is price. And then we want to predict the target variable price based on the features rooms, bathroom, land size, latitude, and longitude. So we pass in the so we create the variable x, and then we pass in our features here into our data frame. And then we want to get a description of our features. So these are this is the description: rooms, bathroom, land size, latitude, and longitude. Third thing is we want to display the first few items in our dataset. To do that, we use the head method from the pandas library. And then if we want to also display the last few items in our dataset, we use the tail method from the scikit-learn library, from the pandas libraries, I'm sorry. So the other thing is we are going to use our decision tree regressor. We can just do it in a few lines of code thanks to the scikit-learn library. So here we from scikit-learn.tree import the decision tree regressor, and then we create the instance of the decision tree regressor, and then we then pass in our training set, which is x, and then we pass in our labels, which is y, as you can see. And then we want to make predictions. So as you can see, these are the predictions. These are the price predictions. And then the other thing I want to talk about is the mean absolute error. So the mean absolute error measures the average magnitude of the errors in a set of predictions without considering their direction. It's the average over the test sample of the absolute differences between prediction and actual observation. So let's say we have this y is our target, this y is our label. For example, the y that we derived from our data set, this is the y. And then this y hat is the predicted value of y. So we want to get the difference between our target value y and the predicted prices. So to do that, we can do that, and then we can divide it by the total number of samples in our data set. So that's what the mean absolute error is. So as you can see here, we can also import the, the mean absolute error from the scikit-learn.metrics, and then we can then make predictions. As you can see, our mean absolute error here is very, very small. It's about 1,105, $1,115. But there's something wrong. We used we use our X value from our training set to make predictions. So as you can see that our model obviously is going to be very, very good because it has already seen the data set in the training set. So what do we need to do? So to make predictions, we need to create a test set. We need to create a test set and then test our model on the test set data which the model has not seen, so that we can evaluate if our model is performing well or not. For example, let's say you are given a math example, and then the next day is the math example comes in a test. The, the chances are going to be you are going to totalize that math test. But if the math test comes with 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 different questions, but from the examples that you learn, chances are that they are going to test if you are generalizing well or not. So to do that, we need to split our data set into training and test set. So to do that, we import the train test split from the scikit-learn library, and then we then use 20% of our data set as the test set. As you can see, 0.2. So it's 20% of our data is this test set. Then we can then create the decision tree regressor instance class, and then we can fit our x train value and our y train values, and then we can make predictions based on our test set, which is the val x. And then as you can see, the mean absolute error is around $277,370. And then our score is around 51%, which is very, very low. So in the next video, I'm going to be showing you how to optimize your decision tree. So thanks for watching, guys. You may click the subscribe button and the notification bell so that you do not miss any of my videos. I'll be releasing soon. Thanks for watching.